Hey, Hernan, how are you doing?
Hey, Dennis. Good. How about you?
Doing great. And hello, everyone. This is Dev Office Hours, and we're going to be demoing some awesome new things that we've added to the ZetaChain developer tooling. I guess we'll just start. So, Hernan, I know you have some new updates on the CLI front. Do you want to share your screen?
Yeah, absolutely. Let me share my screen. I will share the entire thing. Can you see it?
Yes.
Cool. So yeah, basically today I'm going to, display some of the good stuff that we've been working on the CLI front. But I think before diving into the actual commands, it'll be pretty cool to, get an overview of the current DevX application ecosystem we have right now. I think the most notorious applications or repos we are currently maintaining and working on are first, the toolkit, which is an assortment of core utilities, sort of an SDK. I'm going to dive a little bit deeper into this one on the next slides. Then we also have LocalNet, which is basically a local blockchain instance for testing, purposes locally. And then we have the CLI, which is basically a wrapper around Toolkit and LocalNet that is going to make it way easier to run these functions in the terminal as commands. So we are going to dive a little bit deeper on that one too. And then there are a few other additional tools that we are also working on, which we are not going to be diving deeper into today, which are universal kits, standard contracts, example contracts, docs, and many others. So this is the current setup we have nowadays. So basically, both LocalNet and the toolkit are being published through NPM. And what they are doing is basically both LocalNet and toolkit exports functions as commander.js commands, which is basically then imported in the CLI and can then be run via the terminal. So basically, as I said before, LocalNet is a local testing environment. So you can basically have an entire blockchain running in your local system. It's pretty cool because it supports Ethereum, Solana, Sui, and Ton. And as I said before, it is being published in NPM as LocalNet. So let me show this real quick. So yeah, this is the publication on NPM. Then we also have the toolkit, which has a lot of cross-chain utilities, functions for like checking balances, cross-chain transaction tracking. Also, it can broadcast different transactions to multiple chains like Ethereum, Bitcoin, Solana, Sui, basically all of the blockchains we support, including Ton in testnet. And it also has some contracts that can be imported and reused in your projects. So now I'm going to dive a little bit deeper into the actual commands. So basically, this is like the easiest way for me to navigate, the entire CLI. So let me jump into my terminal and let me put this side by side with my browser. So basically, the way you can call our terminal is directly via npx. So you can do npx ZetaChain. Let's see if I have it installed. Of course I do, but it's always good to check. And by the way, this is the latest stable release. So where are the releases? There we are. So basically 5.0.3 is the latest stable release. So I think the first thing we can do here is jump and ask for some help. And this is basically all of the namespaces that we have available. So as you can see, we have options for like creating new examples with a new command. Let me try that out real quick. I'm not going to do it right now, but I still would like you to see how this works. So basically, here we have an interactive command where you can create a new repo for like the call example, hello, NFT swap and token. Let's create one just for kicks. I'm going with hello. Basically, it also outputs the URL for the tutorial, the docs. So if you went ahead and followed all of this tutorial, I mean, you already have the repo, which would be as easy as doing cd hello. And this is a repo you need to follow the tutorial. So that's okay. You can also ask for help in different namespaces, for example, in accounts. And I think this is really cool. It makes it really easy to navigate all of the namespaces and all of the commands. So basically, help will allow you to see what are the commands available for each namespace. And let's say, for example, I want to see what are the arguments each of these commands accepts. We can do something like create is an actual command of this namespace. So if I press help, I will actually see the arguments that are accepted by that command. So that's pretty cool. And then we also have this cool utility, which will basically generate a complete markdown documentation for every single command. This is pretty cool. And something else you could do if you want to like have a quick overview of all of the commands, which could make it easier to dive deeper and investigate in a single place, which is basically, since this outputs markdown, you could do something like create a markdown file. We are going to open this in VS Code. Can you see my screen in VS Code, Dennis?
Yes, we can.
That's pretty cool. So basically here we have every single command documentation. So in case you wanted to, like, for example, search for like ton functions, instead of typing help in every single namespace or whatever, you could simply find it here, which would be pretty useful if you ask me. So let's say ton deposit and call, here we go. This would be, I mean, I think this makes navigation pretty easy. So I guess that's also a really good one to have. So then let's jump into accounts, and basically the account system and also balances. So basically I will use my own trick here, and I will see all of the available commands on the accounts namespace. So basically here we have create. So in case you don't have, or in case you are new to the CLI, it's going to be much easier to query for different things if you have your account already ready and set up. Then, of course, you could delete existing accounts. You can also import an existing account. For example, let's say you use, I don't know, MetaMask in your browser. Then you could export the private key and import it here. This also works for all the other different blockchains we support. Like, for example, you could import your Solana account, your Sui account, or whatever. Then list, it will simply list all of the available accounts, and then show, it will actually display a more detailed overview of a single account. So let's say, for example, I want to see the private key of my Solana account for name Alice. Then it'll be as simple as typing something like npx ZetaChain account show dash name Alice dash type Solana, and that'll be it. But let's basically do something really easy at first. This is the output of the accounts list command. And as you can see, I have a lot of accounts. And so this might not be as easy as navigate if I want to check for a single one. But thankfully, since this can also output JSON, so let me do this real quick. Let's see what are the available arguments for this command. And as you can see, we also have this JSON output, which is going to be really useful in my case, because let's say I only want the accounts that are of name Alice, then you can pipe this very easily with something like JQ, which is what I'm going to do here. And as you can see, that will list only the accounts of name Alice, which I think is pretty useful. It's pretty cool. And since we now know that Alice has an account for EVM, Solana, Sui, Bitcoin, and Ton, we could very easily query for Alice's balances, which is what we're going to do now. But first off, let's take a look at what we have here. So the thing with balances is if you pass a name, it will basically grab all of the available accounts for that user, which is what I listed before with the JQ command. But you can also override certain addresses. So let's say, for example, I want all of the accounts from Alice, but I want a different one from EVM, then I would simply type that address. But for now, let's go the easy route and let's basically list all of the balances for username Alice. And as you can see here, I think this is pretty cool because right now we are only listing the tokens that have some actual balance. This is testnet, by the way, but you could also switch it to mainnet, as you can see here. So basically you have in network, you have choices for both mainnet and testnet. It defaults to testnet, so that's why when I don't pass the argument, it will basically simple default to testnet. But it also has something really cool, which is show zero. So basically, if you really want to see what your balance is on a certain token, you could basically use this option and it would basically display balances for all of the tokens we support, whether they have a positive or negative balance. In this case, I only wanted to check for the ones that have a positive balance, which is why I didn't use this option. But as I said before, you can also override one of the addresses from Alice with a different address, which is what we're going to do here. And here we go. It seems like this other wallet address had a balance on a few more tokens than Alice, which is why there are more options here. There are more tokens listed. So yeah, that's fine. So let's go to the next one. It's pretty cool because you have a single centralized way to query for all balances. So I think that's pretty helpful. So the next thing is cross-chain transaction tracking, which I think is extremely useful because it basically tracks the cross-chain transaction in real time. For demo purposes, I'm going to be running the commands on already existing transactions, but this could very well be a fresh transaction you broadcasted, in some of your apps. So as soon as you get the transaction hash, you can basically start tracking for it. But in this case, and by the way, let me show you what query, the actual query namespace has, because it has a few other things. In fact, balances is also part of the query namespace. So basically, the query namespace has the balances and cross-chain transaction commands. So let's run this bad boy here. As you can see, it has a transaction from Sepolia to ZetaChain, which was successful, outbound mined. And then from ZetaChain to, what is this one? Help me out here, Daniel. Which one is this?
This
is Polygon, right?
Yeah, it's Polygon.
Perfect. So basically, this was a successful cross-chain transaction from Sepolia to Amoy. And by the way, let's also take a look at some of this, at the options of this command. So as you can see, we have a few things here. You can pass your own RPC. Let's say, for example, you have a private RPC endpoint on ZetaChain. You could use something different than the public RPC from BlockFi, which is the one we're using by default. This is a require option, which is obviously the inbound hash. I mean, there's no point in running this command without that one. But there's also a few additional options, which I think are pretty useful. Let's say you don't want to get rate limited by the RPC endpoint. One thing you could do is add a delay in milliseconds, which is basically is going to be the delay used, in the polling. So basically, you could set it up for like, let's try polling every 2 seconds. In milliseconds would be 2000 or whatever amount you consider fitting here. You also have the timeout, which by default is 0, which basically is indefinite. But I mean, let's say you only want to wait for like 5 minutes, then it would be as easy as setting the timeout option here. So let's run another different transaction that wasn't successful like the first one. And as you can see, a transaction from base Sepolia, which was intended, we still don't know for where where the destination chain was, but basically the transaction reverted, and we can see the revert executed transaction here. Okay, let's move on to the next one. So let's go back for a little bit and let's see all of the different namespaces we have here. So as you can see, we have namespaces for all the chains or virtual machines we support. One of them is EVM, which is not obviously a single chain. I mean, there are a lot of EVM compatible chains we support, like Ethereum, Binance, Avalanche, Arbitrum, Base, Polygon, etc., which would all of them would run using this one. Then we also have Solana, Sui, Ton, Bitcoin, and we also have ZetaChain commands, which would basically be for withdrawing tokens to the origin chains. That's pretty much the main use case. But for now, let's try running something on the EVM space. But first off, as I always do, is I think before running any commands, it would be advisable, at least when you're new to the CLI, to run the help command to see what commands are available, also which options each of the commands provides. So here, for example, we have 3 commands available on the EVM namespace, namely call, deposit, and deposit. So let's see what we have on call. So as you can see, there are a lot of different options here, like chain ID, receiver name, private key, etc. It's a lot of good stuff. Then you also have revert options like a forward address, revert address, etc. So let's run this one here. This one is simply going to call a function on a universal contract from base Sepolia. So the way this works is receiver is going to be the connected contract address on base Sepolia in this case. Chain ID is obviously the chain ID of base Sepolia. This is the gateway contract that's deployed on base Sepolia. And then this is a type of the argument I'm going to pass to the function, the value, and I'm going to be using my account Alice to run this command. And yes is simply to skip the confirmation prompt. I could run it first without yes, so you can see what the confirmation prompt actually looks like. But the thing is, running it with -- yes is really helpful for CI, for example. So let's run this one here without the yes prompt. And this is what the yes prompt looks like. I think when you are running this manually in your own terminal, it's probably advisable to use it without the yes prompt. But let's say you're using or running these commands on a CI environment, then I mean, obviously the CI won't be able to like reply with a yes or no answer, which is why we are providing this option here. So let's run it. And here we go. That's a successful transaction. So let me go to the base Sepolia scanner. And here we go. This is our transaction here. This is the account from Alice. As you guys remember, let me go back a little bit to the accounts. And let me list all of the accounts from Alice again. And as you can see, this is the EVM address. I am from Alice, which ends with 78B8, which is the one we have here, 78B8. And let's show some more details. And as you can see, a call function was called here. So that's pretty good. Then let's go back to the EVM. And now let's run something on a different chain, like Bitcoin. Bitcoin is pretty special because you can run commands either using memo or using its inscriptions. We are going to take a quick overview on both of them. So, but first, let's ask for some help in the Bitcoin namespace. Oh, and by the way, some of these namespaces have aliases. Let me show this real quick. So as you can see, some of them, like Bitcoin, for example, can be also called using the B letter, same as ZetaChain, which would be just the Zeta. So let's go back to this. So what I mean by this is we could also do this. npx ZetaChain B help, which would basically be Bitcoin because it's using the alias. So right here, we also have a few different sub namespaces like inscription and memo. Let's see what we have in memo. And by the way, we can also use the aliases for these sub namespaces here too. And as you can see here in memo, we have functions for call, deposit and call, and deposit. Let's do the same thing for inscriptions. And as you can see, we have the same, but also have this encode function because inscription calls need an encoded data to be passed into them. But let's go with the memo first, which is probably the easier. But on the other hand, the thing is, memos used to have, I think, because that's no longer a thing, but memos used to have a restriction on bytes length. I think it was 60 bytes or something like that. I think they removed this restriction not long ago, but before, when that restriction was in place, it was recommended to make very simple calls using memo, like, for example, deposit with no data or with very little data like this. We still support both of them, so we are going to be demoing both. And here we go. This is a transaction hash on Bitcoin Signet testnet. So let's take a look. Let me move this one for a little bit so we have more space. And as you can see, this is an OP return transaction. So you won't see the inscription data because, I mean, it's obviously not an inscription call, but basically here's all the good stuff. So let me go back to the terminal and let's run now the inscriptions command. But basically, I mean, before doing this, we need to encrypt the data. So what I'm going to do is I'm going to be saving the inscription data in a variable, which is then going to make the command much easier to run. But first, let's take a look at what I'm actually doing here. So basically, did I copy this? Yeah, there it is. So basically, I'm running ZetaChain Bitcoin inscription in code, and I'm encoding a few different things like the receiver address, types and values, which is basically the types and the value that I'm going to be passing to the function that I'm calling, and then the revert address here. I'm not going to run this directly because I want to save it in a variable like this. And then I'm also going to be logging it into the terminal. And there you go. That's what your inscription data will look like. So let's now run this bad boy here. And there you go. I mean, this will output a commit transaction ID and a reveal transaction ID. Like I said, for all intents and purposes, I mean, the only one that has something actually interesting is a reveal transaction. So let's go take a look at that one. Let's move this one from now. And as you can see, the previous one had OP return in this field. In this one now has inscription. And you will see that this has more data than the other one. In fact, it'll be as easy as like copying this, and you will see that this is the exact same thing we encoded, which is basically the inscription data. So inscriptions are usually recommended to run for commands that have more data, like for example, deposit and call, which take a lot of arguments. But since the restriction on byte length was removed for memo, I guess they could be used interchangeably. But I would still recommend to use inscriptions for commands that use a lot of data.
Just to add some more info on this, basically, OP return is still useful, but what inscriptions allows you to do is also provide a revert address. So right now, only inscriptions have this capability. But we're probably going to adopt the same format for OP return. But right now, if you need to pass revert address, meaning if you want to return return the tokens to a different address, or you want to be very precise which address is going to get the tokens back, you should use inscriptions. Other than that, yeah, they're pretty much very similar right now.
Awesome, thank you. I actually didn't know that, so yeah, that's a good one. Then I'm also going to be running a Solana gateway function. But by the way, let's follow an approach similar to the other ones. So as you can see in the Solana namespace, we also have call deposit and call deposit and encode. I'm going to be running a deposit and call transaction here. And there you go. This is our transaction hash on Solana DevNet. And as you can see, this is the transaction. Pretty good. So I think that's the end of the demo. Unless, I mean, am I missing something here, something obvious, Dennis? Or I think this was comprehensive enough.
Yeah, I think you covered all the new functionality. So yeah, great demo.
Cool. Great, awesome. Well, that's it for the demo. Thank you, guys.
Yeah, while you were presenting, we actually were joined by Matthew, Dmitry, and Dora, who are currently at ETHCC right now. I don't know if they're still on the call, but if you are, then hey guys.
It doesn't
Yeah,
seem like they are here, right?
yeah, no, I mean they were online, but I guess the event started or something. But yeah, okay, we demoed the CLI. What else? We could also demo the NFT functionality, Universal NFT. Let's see if, yeah, I think we have time. I don't think we have any other questions in
I don't think we
Discord.
do.
Yeah, so let me share my screen. Okay. Okay, you should be able to see my screen now.
Yeah,
And
I can.
yeah, I'll start with the CLI. You've demoed this functionality already, but like for those who just joining, you can use ZetaChain CLI to create new projects like ZetaChain new, and you specify a project like NFT, and it will create a new NFT project. I ran this command just a minute ago, so I already have the project right now, but yeah, you can do it to very quickly get an NFT project. So what is Universal NFT? Universal NFT is ERC 721 extended with cross-chain functionality. If we go back to our docs, I can see. So this is like a high-level overview of what Universal NFT is. Basically, you deploy a contract to Ethereum, BNB, Polygon base, any number of EVM chains, and you deploy a contract to ZetaChain. These are ERC 721 contracts, and what's cool about them is that you can move NFTs between these chains very easily without writing any code. It's all built in. And yeah, let's just go ahead and kind of look into that. We've demoed this functionality before running on localnet, but we can demo it on testnet because it's probably going to be more interesting closer to the actual real environment. I'm going to cheat a bit and have the docs side by side. I don't want to retype everything, but it's pretty straightforward. So after you create a new project with ZetaChain new, you can you should run yarn to install dependencies and npx hardhat compile. We're still using hardhat for this. I don't know if we're gonna fully transition to Foundry, maybe, but for now we're using hardhat. We're gonna keep hardhat compatibility in any case, just because so many developers are using it. So we've compiled our project. Just before we go any further, this is basically the contract. So we have two contracts, one for EVM, one for ZetaChain. Even though there's a lot of code here, it's just Open Zeppelin template. That was intentional. We wanted to make sure that any Open Zeppelin compatible NFT could be upgraded to become a universal NFT. That's why, and like every line that has been modified, we commented it out. Not commented it out, but like we added a comment to it. So it's about like 7 lines of code in total. So very easy to upgrade if you have an existing NFT. So the main functionality is inside a transfer cross-chain function, which is not here. It's imported from the Universal NFT library. So we're not going to go into the details about the code. We'll have a separate video about that. But right now, I just wanted to try running this on testnet and see if it works. So we've compiled the contracts, both contracts. Now we need to deploy the NFT on ZetaChain, and this is quite important because NFTs deployed on other EVM chains like Ethereum and Base are optional, but the contract on ZetaChain is actually required because it handles all cross-chain transfers. So even when you're transferring an NFT from Ethereum to Base, it still goes through ZetaChain under the hood because that's what contracts on ZetaChain do. They orchestrate cross-chain transactions and help move assets and whatnot between connected chains. So first thing I'm going to do is deploy the universal NFT on ZetaChain. And we're using the built-in hardhat task for this. We might transition to commands in the future, but for now it's tests. So this is our contract on ZetaChain testnet. And now let's deploy on Base. So it's very similar. The only difference here is that we're specifying gateway address on base. Here it just uses the default value, but on ZetaChain we also need to provide Uniswap router so that tokens can be swapped. Tokens used for gas can be swapped. I think we'll do just 2 chains for now, just to save some time. But yeah, let's move on. So the next step is, like, after you deployed contracts on ZetaChain and one or more connected chains, you need to tell these contracts about each other. Basically, a handshake of sorts. You need to tell the universal contract, what is a corresponding contract on a connected chain, and we're just going to go ahead and do that. So here we're going to be telling is going to throw an error. No, it doesn't, because I already have base CRC. Basically, before doing this, make sure you specify base CRC20 and specify an address from this list here. So do something like this, but I already had this in the terminal, so it worked. So we told universal entity on ZetaChain about the contract on base. The other way around, we told base about the contract on ZetaChain. Now we're doing the same on base. Okay, so now both contracts should know about each other. And now we can actually mint an NFT. So what this command does is it just makes a call to the contract to mint an NFT. Of course, you can customize, as a developer, you could customize this logic, and you probably should, because you don't want people just be able to mint unlimited number of NFTs, but it's going to be up to you. Right now, we have a function available for users to just mint NFTs, but you probably want to modify this. So yeah, this command is going to mint an NFT and return an ID of this NFT, which is also something you can modify. Right now, we're generating this number based on block height and chain ID, but you probably want to provide a custom logic for this. The only real requirement for this is it has to be unique. So if you customize this function, make sure that NFT IDs minted on different chains do not clash. Otherwise, bad things happen. So don't do that.
What could happen in that case?
Basically, when you mint an NFT with ID 1 on ZetaChain and on base, right? You have NFTs with the same ID on both chains. Whenever someone tries to transfer it, the transfer will fail because it wouldn't be able to mint an NFT with the same ID.
I see. That makes sense.
So yeah, it's not the end of the world, but you probably don't want to do that. So now that we have an NFT, we can actually transfer it from ZetaChain to base. So NFT transfer is gonna, oops. So I'm passing gas amount 5, which is in Zeta, and it might be overkill, but it's gonna take the amount that it needs to cover the withdrawal fee, and then I'm gonna send the rest back to you. So you can provide any amounts. In the future, it would be better if we actually queried and didn't require users to submit gas amounts. So this is just a room for improvement. So what we did here is we basically transferred this NFT from ZetaChain to base, and we have transaction hash. We can now use the new fancy CCTX querying mechanism to actually track the transaction and see it's pending outbound. And while we're waiting, we can go into the Explorer and query for this transaction. So you can see the transaction NFT going from it actually transferred. That was super quick. So basically, on ZetaChain, the NFT was burned, so we transferred it to null address, and the NFT was transferred to base, and now we see that there is a transaction hash on base. So let's go to base Sepolia. Nope, base is Ethereum. Okay, we're in base. Check it out, and we can see that one UNFT, this was just the default symbol, was minted. And if we go, let's see the details here. So yeah, the correct values are here. I'm not going to go into that right now, but I just wanted to see the sender address, contract address. Oh, here it is. Okay, receiver. Let's take a look. Yeah, so this is our contract. You can see that it's a NFT contract basically, and we can just wanted to go back and actually see the NFT on my address. Logs. Here we go. I was looking for my own address. Sorry about that. But yeah, you can, in the NFT transfers section, you will see that an NFT, expand this a bit. So an NFT was transferred 2 minutes ago from null address, basically minted, to my address. And here it is. So the token ID matches the one that we were sending. And yeah, that's how easy it was to transfer an NFT from ZetaChain to base. And now we can transfer it back. So let's do that. The contract is going to be base NFT, destination 0, because we're transferring to ZetaChain. We don't need to specify the destination. By default, it's going to be ZetaChain and base Sepolia. And we don't need gas amount because it's going to automatically compute the value. So let's see if that works.
I think this is one of the instances when we are going to start using chain ID instead of network, right?
Yeah, right now we're still using base Sepolia, but it's kind of confusing. So eventually we're just going to switch to chain IDs and try to figure out how to make the UX better. But yeah, let's go to ZetaChain CLI query CTX hash. And we're going to be observing how it is sent from base to ZetaChain. Let me try again. Seconds.
I think that was the actual output, right? But it was going, on top of the scroll space or whatever.
No, it's not. It was previous output. Let me try doing this here. Interesting. Okay, in the meantime, let's just refresh this page and see that the owner has been updated. So we no longer own this NFT on base, right? It used to be like the NFT was transferred from null address to us, and it was transferred from us back to null address because we were sending it to ZetaChain. Okay, yeah. I don't know, maybe an RPC glitch, but now we can see that the NFT was transferred, and we can go back to ZetaChain Explorer, and this is the corresponding transaction where an NFT was transferred from null address to me, and if you go and search for the NFT by ID, you can see that I'm the owner. So
that's an insanely long ID, by the way.
it is, but it's unique.
Yeah.
So yeah, we can also track the whole path, right? From this NFT being minted, then transferred to Base in this transaction 7 minutes ago, and here already transferred back from Base to ZetaChain. It's pretty cool. It was very fast. That kind of surprised me, but the connection on testnet with Base is very fast. It's really good for demos. But what I didn't demo is the transfers between connected chains. We can do that as well, but it basically works the same way. So you can transfer an NFT from Base to Ethereum, from Ethereum to Polygon. So it's very easy to kind of move the assets between chains. So yeah, if you want to build an app that needs assets that are easily transferable between a bunch of EVM chains, then this is a great tool. And of course, we also support fungible tokens as well. It works exactly the same way. You can have ERC20 tokens that you can transfer between chains the same way as NFTs. So it's really versatile. Cool. Well, yeah, I think that's it. Let me just stop sharing my screen. And we're going to be kind of improving the tooling around this, make it even easier. I don't know if it's possible. It's already just a few commands, but yeah, just wanted to share this piece of tooling that we have. It has been, oh yeah, by the way, I didn't mention, it has been audited. So yeah, we have audit report on GitHub, and yeah.
Yeah,
Pretty
I
cool.
think next in line is going to be make this easier to consume from front-end applications too, instead of just a terminal.
Yeah, so we made a lot of efforts to add this functionality to the CLI, right? It's super easy to run it from a terminal by installing the CLI or by running it directly from npm. But of course, many developers want to import these functions like EVM deposits, Solana deposit and call, all this good stuff. And we're in the process of making these functions available and compatible with all the different signers and just as reusable as we can. So yeah, I think it's going to be shipped like in the next version of the toolkit, which is pretty cool. So yeah, let me see if we have any questions. I don't think we have any. Yeah, cool. I think that's it. I think we covered a lot of grounds here. Demoed the CLI, showed universal NFTs, and yeah, if you guys have any questions, of course, welcome Dev General on ZetaChain official Discord. Happy to help you there. And yeah, Hernan, do you have any other things you want to share?
I don't think I have anything else. I think overall we made a really, really thorough walkthrough. So yeah, it was good to see.
Awesome. Well, thanks so much for the demo, and thanks everyone for joining. See you in the next one. Goodbye.
Awesome. Have a good one, guys. Bye bye.